Under this competency, we have already finished types of nerve fibers, and we have also discussed about the functions of the nerve fibers. And today, the part which comes under competency 3.2, that is properties of nerve fibers, including strength, duration curve, chronaxy, and Rio base. It is written like that in your syllabus. So we'll cover today the properties of nerve fibers. So these are the properties, we'll be discussing one by one. These are the important properties that we will be learning. Among these, very important ones are excitability, because under this property we will be learning action potential. Okay, so within this action potential, there comes refractory periods. Okay, so though separately it was mentioned there as one of the property, refractory period, so it will be discussed when we will be discussing about the excitability. Then there is conductivity. The main purpose of the nerve fiber is to generate nerve impulse and to conduct it. So how this nerve impulse is generated and how these are conducted along the nerve fibers, that we will study. How these are conducted in myelinated nerve fiber, how these are conducted in non-myelinated fiber. Very important. So question you may expect from here. You may expect questions from excitability. Here, under this excitability property, you will learn other things, say stimulus. What are the different types of stimulus? What is stimulus? And what is the relationship of strength and duration of stimulus? That is that curve we have to study in depth. What is Rio base? What is chronaxy? So all this, everything is coming, almost all the important aspects are coming under excitability. All or none phenomena, it is another important, it is not so, it may come, say, as maybe in your MCQs or as short questions. All or none phenomena means whether if nerve fibers are adequately stimulated, if it is stimulated, it will produce response. If it is not adequately stimulated, it will not make any response. So that is all. And when it is stimulated, it will produce with all its action potential will be certain characteristics. So with all these characteristics, it will produce the action. Means impulse. So when these are not properly stimulated, they will not produce at all any action potential. So this is all or none law. There is again another refractory period. We'll discuss what is refractory period. There is accommodation, infatigability, and summations. And there is another property may not be so much important for you, that is adaptations. So another property is there. Number 8 property is adaptations. So let us start with excitability. So you see, main function of the nerve fiber, what I said, generation of action potential. We also call it spike potential. We also call it nerve potential. So all are synonymous. Okay. So nerve impulse, action potential, spike potential is a synonym. Same meaning is same. And the nature of this action potential generated in nerve and generated in muscles are different. We'll see how different it is later on while we will be studying about the muscles. So their nature is different. Refractory period, these are different. All or none of these, they're going to be different. So while studying the main, that is what I said, what is the main function of the nerves? Generation of nerve impulse and to conduct it and to pass it to another neuron. From one neuron, transmission of nerve impulse from one neuron to another. To perform this, we need to know certain aspects which are very important, otherwise we will not be understanding it properly. Means you are already known that every living cell has got resting membrane potential, and because that means what, the inside and outside the cell membrane ions are unequally distributed, and we have explained why these are unequally, how distributed and how resting membrane potential is generated. Now we will not be discussing it because this is a separate part. So you can expect a last type of question from this, that is how resting membrane potential is generated. So for generation of resting membrane potential or nerve impulse or excitation, so now the cells, the excitable cells or living cell must have channels, must have ion channels, and there are different types of ion channels for different ions. There are ions for sodium, there are ions for potassium, ions for channels for chloride, calcium, ions for chloride ions. So there are different types of ions for different ions. Now we can broadly classify these channels into three categories. Some are simple channels or leaky channels. These are non-gated, there is no gate, there is no control across the channel. So these are non-gated channels, or simply we call them leaky channels. So these leaky channels there are leaky channels for sodium, there are leaky channels for potassium, there are leaky channels for calcium, chloride ion also. So other than these leaky channels, another type of channel is there. These are called gated channels. Means there will be gate. So at the opening of the channel or at the other end of the channel, there may be gate. Activation gate, inactivation gate. This sort of gate may be. There may be presence of only one gate. So these are gated channels. Now how these channels will open? How this gate will open? How the channels will be opened? Okay, these channels may be opened by three different factors. One is by voltage. When the voltage across the membrane will be such that in a particular voltage, difference of voltage across the membrane at a particular voltage, the ion channels, these channels open up. Okay, and if this voltage is not achieved, when this voltage is not achieved, the voltage will remain closed. Only during that part, say for example, in case of nerves, this will open at minus 55 millivolt. When this membrane potential across the membrane will be minus 50, difference is minus 55 millivolt, then the gated channels, voltage gated channels open up. Okay, so and these are very fast, opens very fast. In case of sodium, it opens very fast, closes very fast. But potassium ion, these are slow, opens slowly, closes slowly. Okay, so there is different. There is gated channels for calcium also. So voltage gated. So these are all voltage gated. So then there is another type of gated channel, that is ligand gated. I already discussed earlier what are ligands. Ligands are chemical substances. So like hormones. Okay. So when these ligands bind with the receptor on the cell membrane, then only channel open. So these are ligand gated. For example, acetylcholine. When acetylcholine binds, we'll see it during transmission of nerve impulse across synapse, across neuromuscular junction. We'll find different types of ligands, say gamma aminobutyric acid, acetylcholine, glycine, noradrenaline. So these are histamine. So these are ligands. When these ligands binds, then only gate opens. Okay, so these are ligand gated channels. There you will also get mechanically gated channels. These are present only in receptors. These are present in receptors. So when the receptors are mechanically deranged, then the channel is open up. So it is also there in baroreceptors. With the help of the baroreceptor, we control our blood pressure. There is chemoreceptors. With the help of this baroreceptor, we control our, when blood pressure is too much, this baroreceptor is stressed, so they produced action potential. It goes to the center, so it takes the action how to control this blood pressure. So this type of receptors we can also get by which the channels. These are mechanically guided channels present in these sort of channels present in mechanically activated receptors. For example, baroreceptors. Okay. So let us see, the sodium channels are very important. So we are studying the nerve. You will find along the nerve fiber in axon, what is their myelin sheath, there is node of Ranvier, there is axon hillock, there is soma, there is dendrite. See, you see from these how these sodium channels are distributed. Mostly they are distributed in the node of Ranvier. Then it is in the axon hillock. Because when nerves produce nerve impulse, they are actually produced in the axon hillock. They are the triggered zone from which action potential is triggered. So this axon hillock is also called triggered zone. So the triggered zone of nerve fiber or neuron, they actually are capable of producing nerve impulse. And the node of Ranvier, they can also produce action potential when they are stimulated at that point. If you stimulate a nerve in the node of Ranvier, they can produce action potential, they can be propagated. Otherwise, they are normally stimulated. They can also produce action potential, but not by their own. When any action potential coming from the axon hillock, they will cause stimulation of the node of Ranvier. There are channels, so they will be opened up and their action potential will be produced. So you see, mostly now you will find the sodium channels in node of Ranvier, then it is in axon hillock, and it is cell body in dendrite. These are relatively less. In axon terminal, it is 20 to 75 per square micrometer. In unmyelinated nerve neuron, there is only 110 channels per square micrometer. So the distribution of channels this is one of the reasons why conduction of nerve impulse in non-myelinated nerve fiber is relatively less than the myelinated nerve fiber. Okay, so these are the concepts you must have. So before understanding action generation of action potential, depolarization, repolarization. Okay, now see, while we have studied the resting membrane potential, we have seen sodium ions are distributed more, their concentration is more outside the cell membrane, inside it is less, whereas the potassium ion, inside it is more, outside it is less, and chloride ion is outside it is more, inside it is less, and insoluble ions, impermeable ions like phosphate ion and protein ions, their concentration inside the cell, inside the membrane is more. So because of this unequal distribution of ions across the membrane, when there is unequal distribution, there is more net charge. Positive charges are more outside the cell, and net negative charges are less within the cell. As a result of what? As a result, what will be there? There will be a potential difference. Under resting condition, this is called resting membrane potential. So in case of nerve, how much is this? So this is the cell membrane. Outside, this is outside the cell, and this is inside the cell. So inside is relatively negative, and its negativity is minus 70 millivolt in respect to outside. So how these are recorded? How this membrane potential can be recorded? This can be recorded by cathode ray oscilloscope or voltmeter. Okay, so if we place one electrode here, another outside membrane, under resting condition, we will see a deflection which is minus 70 millivolt. Let us see what happens if you continue this recording over time. This is time. So resting membrane potential is, so we are recording resting membrane potential over time. So what will be? There will be a straight line. There will not be any change since it is resting. Every time difference is minus 70 millivolt. Now what I am doing, I am going to stimulate this nerve. Electrical stimulation. So this is the nerve and this is stimulation. Now what is stimulation? Let our concept be clear. Can anybody tell what do you mean by stimulus? Anyone? We have external environment. We have internal environment within the body. If there is any change in the external environment or internal environment, it will make response in our body, in the organism. So, what is stimulus? Capable of changing the environment, internal or external, capable any agent, any factor, anything that are capable of changing. See what sound is coming. So this sound has changed our environment. So accordingly we could respond to this. It is disturbing us. Okay, so in this way they can make response. Suddenly, if I run all these AC machines, then what will you feel cool? So environment will be changed. We will respond accordingly. So now I think you could realize what is stimulus. Stimuli is the plural form. Okay? Hello? Now can you tell me what do you mean by stimulus? And because of this, it will produce some response in the body. Means capable of producing response in the body. They are stimulus. Now it is clear to you? So this is stimulus. Now these stimuli or stimulus are of different kinds. There are external stimulus, sound, light. So these are external stimulus. And internal stimulus, pain, or change in pressure within the body, change in chemical within the body. So that will be changed. That will change the environment. Because of this change, there will be some receptors, they will be responding because of this change, and they will make some change in my body. I'll feel pain. We have certain receptors on our skin, and they detect the changes in the environment. Either it is in external or in the internal. So as a result, what will happen? There will be production of change. In case of nerve, what will be the change? If I change the environment of a nerve fiber, there will be production of nerve impulse. There will be production of action potential. Now, all the stimulus are not capable of producing change, not capable of producing action potential. Okay? Why? Because of maybe two factors. One is maybe because of their strength. Whether they are capable of producing the change or not, it will depend on what? Strength and their duration of exposure. And that relationship between strength and duration, we call it strength-duration relationship. It is expressed through a curve. We will express it. We will explain it. So we can see the stimulus, all the stimulus are not capable of producing change. Those who are capable of producing the change, the intensity of the stimulus that are capable of producing the change, they are called threshold stimulus. What? Threshold stimulus. Okay, and so it is the strength of the stimulus just capable of producing the change. And if the strength is less than threshold, then there will not be any expected response. There will not be this stimulus will not be producing any response because they are sub-threshold. Now, some stimulus are threshold, they can generate impulse here, nerve impulse, but while we sleep, that strength of that stimulus we are not capable of producing action potential. That's why we cannot sense that. Okay, so it varies depending on the excitability of the tissues. So that is another important aspect. So whether a stimulus will produce nerve impulse or action or response, it will depend on what? The excitability of the tissues. All the tissues of our body cannot produce action potential. Only the excitable cells, though all cells are having resting membrane potential, but all cells, living cells cannot produce action potential. Who will produce action potential? Only the excitable cells. Who are excitable cells? Capable of producing action potential. What are those cells? Nerves, muscles. They can only produce action potential. So this is important. Now, what are excitable cells? Capable of producing action potential. Okay, these are which type of cell can be produced? The nerve tissues and the muscle tissues. We know there are three types of muscles. So their action potential also differ. You will find action potential produced by cardiac muscle is different from smooth muscle, and the action potential, they also differ from cardiac muscles. So we will study that part. So we understand, we could know what is subthreshold stimulus, what is threshold stimulus, and what is suprathreshold. Suprathreshold, more than intensity is, threshold is just capable of producing response. Just capable. I have stimulated, but strength is less. So there will not be production of any action potential here. I increase the intensity? No. Again I increased? No. Again I increased? No. Again I increased? Okay, now action potential I got. So this is the threshold. And even after that, after threshold, if you do increase, same response. Means supra-threshold value will also produce same response. This is all non-low. See, when it is sub-threshold, no response, no action potential. When it is threshold or more than the threshold, then we will produce identical response. The nature of this action potential, whether it is just threshold or supra-threshold, will remain same. So this is all or none law, all or none phenomena. Understood, everyone? Okay. একটু ব্যাক করতো See, what I am doing, resting membrane potential, and this is the time. This is time, and this is what? The potential difference across the membrane. So our potential difference was at minus 70. Minus 70. Now what we am doing, I have stimulated the nerve. As a result, what will happen? Some sodium ion, some sodium gates, sodium channels will be opened. Outside concentration is more, so some sodium ion will enter with its positive charge. So inside will be more negative or less negative? Why outside is positively charged? More positively charged ions are there. Inside, less negative positively charged ions. So if I stimulate this area, the sodium channels will be opened up. Sodium ion will enter within the cell. What will happen to the charge? This positive charge will neutralize some negative charge. Again, if some more sodium ion enters, it will again some more positive negative charge. As a result, negativity will be changed. Means the change will proceed towards positivity. Minus 70, minus 60, this way. Ultimately, if continues it may go to 0. It may proceed to 0. If a further sodium ion enters, it may go towards positivity. So if the potential changes towards positivity or exceeds 0 or remains below 0 but less than minus 70, then this change is called depolarization. This is called depolarization. Means that, so what happened here? After stimulation, see, the resting potential has changed it's changed. Because of the stimulation, it is changing, but not coming to the threshold level minus 55. So it may be minus 72. Thereafter what? The change, it has made some change across the membrane, potential change, but immediately it came down to resting membrane potential. Because of what? Can it feel? Because of two things. One is permeability of the ions. Sodium ion outside more, inside, but potassium ion inside is more, so potassium ion will go out. If one sodium ion comes, one potassium ion, these are not active transport. Beside there is sodium potassium ATPase. Beside there is sodium potassium pump. Here, when it is changed, immediately the pump will start operating. The sodium ion that has entered, it will be coming out. As a result of this, within very short period of time, this change will be coming back to the normal. Let's see, I have now increased the stimulus, strength of the stimulus, but not threshold, below the threshold. What will happen? The change in membrane potential will be more than this. Will be more, since strength is relatively more. So again it will continue, and thereafter shortly it will be coming back to normal. So resting membrane potential. Again, if I increase the strength, this will be the change in membrane potential. Again I increased, but the change is not reaching to minus 55. So before that reaching, it again came down to normal. So see, these are graded. Isn't it graded potential? These are called graded potential. We have stimulated the nerve with sub-threshold stimuli. Sub-threshold, these are all sub-threshold stimuli, but their strength is relatively more and more. None could produce action potential. Now I increased further. As a result, strength, as a result, the change in membrane potential reached to minus 55. When it reached to minus 55, it made a firing. It is called firing. It fired. It produced a spike. The action potential produced a spike when the membrane potential exceeded minus 55 millivolt, exceeded the threshold millivolt. Now there will be rapid change in membrane potential. This rapid change in action potential, when it reaches the threshold potential, this is called action potential or spike potential or nerve potential. So this is how action potential is generated. Now see, these are also potential but they are graded potential, not the action potential. And their nature is they are unable to propagate this potential across the membrane, across the nerve fiber. Means this sub-threshold, one of the important characteristics of this graded potential is they are not capable of propagation. They cannot be propagated. But the action potential produced, they can be propagated. They can be transmitted across the membrane. Only action potential can be propagated, can be transmitted. But the graded potential cannot be propagated. So if we apply a stimulus to a nerve fiber, two types of potential will be generated. One, graded potential. This for the stimulus will be subthreshold, and another is action potential. And stimulus must be capable of producing potential say at least up to minus 55 millivolt. Tomar kaaj holo only to change the membrane potential stimulus. You just bring the change in across the membrane potential. Whatever the potential is across the membrane, you bring it to minus 55. Then it will be capable of producing the fire, producing the action potential. So now, what happens here? What happened there? Why this happened? Why there is rapid spot of change in my membrane potential? Because before that, during this period, during this time, only leaky channels opened. When I stimulated, only leaky, through this leaky channel, slow amount of sodium amount or very less amount of sodium ion could enter. As a result, there is such change. When the change of this resting membrane potential came to minus 55, all the voltage gated channels of sodium opened up. Since outside sodium ion is very high in concentration, immediately sodium ion will be rushing into the set and will bring the potential difference towards positivity, and thereafter to reversal of potential means plus 35 millivolt. Plus 35, see. So it is gradually increasing. This potential when this minus 55 exceeded, then potential came to plus 35 millivolt. So there is reversal of potential. Outside it was positive, it was initially positive, now outside is negative. Inside earlier, when it was under resting condition, inside was negative charge, now it is positive. Reversal of potential. Okay, so when action potential is generated, what you will find? Reversal of potential. So again, you think what is happening? You are applying subthreshold stimulus, so there will be membrane potential, but these are not capable of producing action potential. When you apply the strength, such a stimulus of such a strength that is capable of producing resting membrane potential of minus 55. When it reaches the minus 55, immediately all the first voltage gated channels open. As a result, more sodium ion entered, lot of sodium ion entered and made inside positive and outside. Since sodium is coming outside, from outside to inside, leaving the negative charge ions, so outside will become negative. Now, what will happen after that? So, we learnt what is stimulus and external, those who want to study more about internal, external, we will go through the slides. Strength duration curve. Okay, let's take this example. This is time. Strength of stimulus. Here we are applying electrical stimulus. Let us see. Stimulus given. Cathode ray oscilloscope recorded no potential change or only graded potential it is noted. No action potential. So time is passing. So now what will happen? We increase the stimulus. Strength of the stimulus we have increased. More than this. Again we observe no action potential. Again we increased. Again we increase the stimulus, strength of the stimulus. Every time we are increasing the strength of the stimulus. Now what will happen? After some time we found it produced action potential. In the cathode ray oscilloscope, we found action potential. Okay. So after this much time, so with this strength, I have to spend this much time. This is the activation time. This is called activation time. So with this strength, I have to, for long period, this much period, I have to go carried on putting stimulus. Then only in the nerve, action potential developed. Okay, I increased the strength. Now I see, I do not have to wait for this. Before this period, within this period is shortened. Period is shortened. When we increase the strength of the intensity of this stimulus, time is shortened. Again I increased, again time is shortened. Again time is shortened. Again I did it. Whether this strength is capable of producing action potential? No, na? So no action potential we got. But with this strength, we got one extra action potential after this much period. So this is the minimum strength. This is the minimum strength that is capable of producing action potential. That is Ryu base. It is the Ryu base. So this strength is the Ryu base. Now I did one thing. I doubled the strength of the stimulus. I have seen what is the Ryu base. What is the strength for Ryu base? Just capable of producing action potential. Oh, this much. Okay, I just doubled it, the strength of the stimulus. Then I put the stimulus on the nerve. Now I see this is the double the strength of Ryu base. Now I see the time is only this much. Thereafter, again I increase the strength 3 times of Ryu base, 4 times of Ryu base, 5 times of Ryu base. What is happening? No further shortening of time. So now if you draw this curve, you will get the curve relationship. This curve is called strength duration relationship. And this time, this is the minimum time. Minimum time for exciting a nerve. So this giving double the strength of Ryu base. So this minimum time is called chronaxy. So this is chronaxy. Chron means time. Chrona means time. Chronaxy, it is the minimum time to excite a nerve tissue. Minimum time to generate action potential in a nerve tissue. Giving stimulus ta ki hote hobe? What should be that stimulus? Double the strength of Ryu base. Ryu base is what? Voltage, current, voltage with which we can excite, minimum voltage with which we can excite a nerve. So that is the Ryu base. Now what we did, double of Ryu base strength of stimulus, we applied it and observe what is the time. So this time is called chronaxy. So what is the importance of chronaxy? Chronaxy determines the excitability of the tissue. How much excitable a cell is. Whether the cell is dead, excitable cells, whether the excitable cell is dead or partially dead or if there is some injury, means with chronaxy you can assess how much the nerve fiber is damaged, functional damage. So you can assess the functional damage of a nerve fiber using this relationship. So this is the strength, Lewis, initial, this strength, they could not produce any response. So flat line. So here also I increase the strength, flat line, no response. When I gave stimulus here and waited for this much time, then response is produced. So thereafter I increased, time is reduced. Increased, time is reduced. Increased, time is reduced. So this is double of this reverse. So this is the time required to stimulate to generate the action potential, nerve impulse. So this is Concisely. Could you follow this? So this is strength, duration, relationship, and Lewis Concisely. What is the use of Concisely? What is the significance of Concisely? We can assess the excitability of a cell, of a excitable cell, of nerve fiber. If the Concisely is increased, that is, it is losing its excitability. Okay, let us explain different parts of action potential. Now, these are the definitions of action potential. Learn it. So, what are the action potential? Transient change. Transient change in membrane potential. It was resting potential, so cell will be depolarized, potential will be changing, there will be depolarization and there will be firing, means reversal of potential, then again it will be coming to normal and it may go beyond normal, thereafter it may come back. So this transient change is called action potential. When action potential is generated in nerve impulse is formed and it is propagatory in nature. It will pass along the nerve fiber. When action potential is generated within a muscle fiber, it will cause contraction of the muscle. Either it is a cardiac muscle, or it is a smooth muscle, or it is a skeletal muscle. So first, to contract a muscle, first condition is there should be formation of a action potential. Then response in the form of contractility. There we will study not conductivity, we will study the contractility. That is the property of contract. Nerve cells has no contractility. They cannot contract. But when they are stimulated, nerve cells when they are stimulated, they can produce nerve impulse. But muscles can contract. It is also called sequence of events along the membrane of excitable tissue in response to a threshold stimulus. You learned that. If it is sub-threshold, no action potential will be developed. So it must be at least of threshold value or of suprathreshold strength. Every cell has a membrane potential, but only excitable cell like muscle and nerve can exhibit a reversal of electrical polarity. What does it mean? We have seen when action potential is generated, outside became negative instead of positive. And inside, instead of negativity, it became positive. This is the reversal of potential. So in other cell, non-excitable cell, this will never going to happen. These are the different parts, different phases of action potential. say resting membrane potential as minus 70 millivolt is coming, I stimulated at 0 time, I stimulated the nerve. So what is happening at minus 70 millivolt? I have applied the stimulus. I have applied the stimulus, but this stimulus could not bring the membrane potential to minus 55. So gradual means here will be graded response. So first there will be graded response. Graded response, when this graded response reaches to this level, means minus 55 threshold level, then suddenly what happened? There is a rapid change in membrane potential towards positivity, not towards this, towards positivity. So this part is called depolarization, from here to here. Change in potential towards positivity. This must change. This change is also depolarization, because this change towards positivity. If change is this one, this would be more negativity. Means cell is going to be hyperpolarized. Then instead of depolarization, there will be hyperpolarization. As a result, the excitability of the cell will be reduced, because excitability depends on RMP. Less the RMP, more the cell is excitable. More the RMP, less the excitability. So, if voltage change is made towards this, the cell is going to be hyperpolarized. Now it is change is towards positivity, that it is called depolarization. So, when this depolarization attains threshold level, that means minus 55, then what happens? Suddenly all the voltage gated channels, sodium channels opens. As a result, there will be rush of sodium channel inside the cell, inside the membrane. So voltage will be changed towards positivity, and this part is called overshoot, since it is going beyond 0. So that's why it is called overshoot. S is WT, overshoot. And it happened, why it happened? Because of opening of voltage gated channels. These are, I said, these are very fast. When this open, sodium ion can rapidly get entered, and they remains open very for short period of time. Very short period of time. And thereafter automatically it will going to close. So within this time, all the sodium ion is entering. Not all, most of the sodium ion are trying to enter within the cells and bringing these changes. And why it has stopped there, plus 35? Because voltage gated channels closed, I said, they opens fast, closes fast. When the membrane potential became plus 35, then also concentration of sodium ion still more outside. But they cannot enter, why? The gate is already closed. That's why it has stopped at 35 millivolt. Now what happens? Then what happens? Actually, when minus 55 millivolt threshold potential came down to minus 55, then sodium channel opened up, voltage gated. At the same time, potassium channels also opened up. But our potassium channels are very dhila, slow, open slowly, closes also very slowly. Potassium channel could open only at this time. At this time. Started opening here. But the amount of potassium coming out is very less. When this much time is gone, then only potassium channel opened up. So by this time sodium channel closed. Now what will happen? From inside potassium will be going out. Inside concentration of sodium, potassium is more. Now potassium ions will be going out. As a result, what will be there inside the cell? Again, gradually it will coming towards negativity. Sodium ion is still within the cell, but in exchange of sodium ion, potassium is coming out. Only the exchange could take place. Sodium trapped within the cell, within the membrane. But potassium ion is not trapped. Potassium is, because of concentration gradient, potassium ion started coming out. Now the channels are open. As a result, again this potential, so here you can see opening of potassium ion, voltage gated channels. So as a result, potassium ion are coming out. Still some more potassium are coming out. As a result, resting membrane potential go beyond minus 70 millivolts, say minus 80 millivolt. Why it happened? Because still potassium ion remained open. Then what happened? Again, this membrane potential is coming back to my normal. Why it happened? Why it came back to normal? Potassium channel closed. Sodium potassium ATPase pump started. क्या हुआ? इनसाइड में ट्रैप्ड हो गया सोडियम, आउटसाइड में ट्रैप्ड हो गया पोटेशियम. रिवर्स हुआ ना. नॉर्मल तो ऐसा नहीं था, पहले तो रेस्टिंग कंडीशन में ऐसा नहीं है. तो व्हाट आई हैव टू डू? ओके, ब्रिंग इट बैक टू नॉर्मल. सोडियम what you have entered within the cell, you come out. Potassium you went out, come back to normal. So the pump will do it. For exchange of 3 sodium ion, there will be 2 potassium ion. So in this way, the resting membrane potential will be coming back to normal. So what are the different parts? So this is slow depolarization, fast depolarization. This is the slow part because of graded potential, and this graded potential, when it arrived at minus 55 millivolt, it produced this spike. Okay, so this is first depolarization. Now this is repolarization, coming back to normal. So initial part of is called, this is hyperpolarization. Again another curve you see. Rapid falling phase of repolarization, and this part, the first part means this is falling rapidly. This rapid falling phase of repolarization is this part. But it took less time to come from here to here. But from here, the repolarization is slow. This is called after depolarization. And this part is, the slower part is after depolarization, and when the membrane potential coming below the resting membrane potential, that is called after hyperpolarization. So here, why it happened? Because still some potassium ion is going out, and here sodium potassium pump started operating. This action potential, generation of action potential, this normally takes 1 millisecond to 4 millisecond. 1 millisecond to 4 millisecond. And depolarization takes only 0.1 millisecond. Repolarization takes rest of the time. So depolarization is fast, repolarization is slow. And we can see now we are in a state of explaining the properties. Now we learned what is action potential, what is depolarization, what is repolarization. Okay. Excitability. What is excitability? The ability to generate action potential. It depends on what? Resting membrane potential. Higher the resting membrane potential, less will be the excitability. Less the potential, more will be the excitability. Okay. And these are exhibited by excitable cells, muscles and nerves. Next is conductivity. The action potential that was generated, now generated where? Generated in the action hillock or in the node of Ranvier. Now this action potential will be transferred from one along the membrane, along the nerve fiber, along the axon. So this is the conductivity. This conductivity depends on 3 factors. One is myelination. If the axon is having myelination, the conduction will be faster. If it is not having, conduction will be slower. This is number 1. Number 2 factor is diameter of the axon. Diameter of the axon or diameter of the nerve fiber. We have classified nerve fibers according to the diameter, according to the velocity of nerve impulse passing across, passing through the membrane. So, second is diameter. Higher the diameter, faster will be the velocity. Higher the diameter, faster will be the velocity. Then the temperature. Higher the temperature, more will be the velocity. Okay. Transmission of nerve impulse in myelinated and non-myelinated. I said in non-myelinated it is slow, in myelinated it is faster. Why it is faster? Because the loop, voltage loop, action potential is formed only in the node of Ranvier. As a result, the speed is faster. But in case of non-myelinated, just adjacent places, they go on changing adjacent slowly, so they can advance slowly. So this is another difference. And diameter I said, and the temperature I said. Okay, so it will depend on this. Conductivity, all or non-low, we have seen, if it is half threshold, no action potential is generated. Once generated, it will have all the features. Means it will be having spike, it will be all the phases it will be having. Not only this, they will be propagatory. This action potential will be propagated, but those potential, local potential or graded potential, they are not propagated. Okay, so this is all or none law. Refractory period. Refractory period means, I'll take 5 minutes more. ভোর হয়ে গেলাম রে আজকে। This is what action potential. Action potential. This period is called, means threshold potential from this deploration and part of reploration. This time is called refractory period, absolute refractory period. Why this has happened? During this phase, if you apply second stimulus, it will not produce any effect. This is not going to produce a second action potential, because during this period, the nerve remains in a refractory change, refractory status, means it will not act. It will not respond to a second stimulus. But during this phase of action potential, the later phase, it is called relative refractory period. Why it is relative? If your strength of the stimulus is much more than the threshold, then it will be capable of producing again another action potential. But condition is, strength of the stimulus must be much more than the threshold stimulus. But during absolute refractory period, earlier phase, whatever be the strength, it will not going to produce any second action potential. Okay, so because for generating action potential, nerve has to come back to the normal stage, resting membrane potential. Okay, so that is all our non-law. What is the another law? What is other law? Infatigability. Muscles can be fatigued. So I started doing this. After some time, I will not be able to sustain contraction. But nerves are not like that. Why? Because of refractory period. Because of the short refractory period. So within this period, they can come back to the normal. So as a result, you cannot make them fatigued. So this is infatigability. Next, what is this? All or none law I said. Infatigability, what are the other properties? Summation. See, at the initially graded response. So if you continuously, if you are applying stimulus, but these are sub-threshold. But if you continuously add on, if you continuously stimulate with sub-threshold stimulus, this stimulus will be added. And when they will be added, they will be capable of producing action potential. They will be capable of exceeding threshold limit. Means sub-threshold, but first, one after another, no gap. Then they will be summed up. As a result, they will be able to reach the threshold limit. So this is summation. And other accommodation. Adaptability. Adaptability means if you go on with suprathreshold stimuli, provide giving stimulus to a nerve fiber, what you will find gradually its resting membrane potential is coming down to more negativity. Now it means the nerve is getting less excitable. When you repeatedly provide suprathreshold stimuli repeatedly, as a result, what will happen? The resting membrane potential will not be minus 70 millivolt. It will be minus 80 or minus 90 millivolt. So now it means it is less excitable. So it is for our good only. Pain. So you are going stimulating. So after that, okay, do it. But I am not feeling so much of pain then. So this is adaptation. It happens. See. Very good smell. So after some time you don't get the smell. Your sense organs at the nose, they are adapted to this smell. But other can find it. So adaptation you will find. So these are all about properties of nerve fiber.